All right, we're in the third part of this question. So we're going to revolve R3 about x equals 1 line. Here we go. That's x equals 1. Okay. So x equals 1 is a vertical line. So we're going to find slices, or we're going to have slices perpendicular to that line. So that means we're going to go with horizontal slices. Okay. And this comes with thickness dy. And if you revolve this around, let's see, x equals 1 vertical line, what do you have? So we're going to have just a disk with thickness dx, okay? And all I need is little r here, right? The radius of that disk. Okay? So let's start labeling. Let's say like this disk is y units far from the x-axis. Okay? So let's say like this disk is y units far from the x-axis. So I need this distance here. And that distance is determined by the blue curve. Okay? And the blue curve is y equals x squared, but I need x of that. So I'm going to rewrite this as x equals radical y. So for that reason, this will be radical y. Okay? Well, starting from y-axis all the way to x equals 1 vertical line, the distance is 1. Okay? So this distance here, in other words, all the way from here to here, okay? That's 1. So that makes this part here, r, to be equal to 1 minus radical y. Okay? Let me just clean that part so you can actually see this better. Okay? All right, so I'm going to write down the volume of the representative disk to be pi times 1 minus radical y squared times dx. And check that out, within that light blue region, R3, x's are ranging in between 0 and 1, and as well as y's, right? By the way, this should be y, I'm sorry. I just said it wrong. Because the thickness is dy, right? So I'm sorry. And all the y's are ranging in between 0 and 1 within that light blue region. So I can go ahead and write down the volume as like pi integral from 0 to 1. Okay? 1 minus radical y squared dy. So this is a dy dependent integral. Right? All right, so let's expand this out. 1 minus 2 radical y plus y dy. I think we can integrate this in one shot. Pi y minus 2 y to the power of 3 halves divided by 3 halves, because this is equal to y to the power of 1 half, and we can use the power rule for integration. Okay? Plus y squared over 2 from 0 to 1. Okay? You can use the fundamental theorem of calculus. So pi 1 minus 2 over 3 over 2. That makes it 4 over 3. Plus 1 half minus pi times the lower limit plugged in, but that's 0. Okay? So if you simplify this, you're going to get 2 pi over 15. All right, so the volume obtained by revolving R3 about x equals 1 a vertical line is going to come with the volume exactly equal to 2 pi over 15. Okay? This takes care of part C or part 3, whatever I named it earlier. Okay, C or 3. I'll just call it C. Okay. We have only one part left, and I'm going to work through that in the next video. Please move on to that. All right, I'll see you there.